Hello everyone, this is Ed the Audio Nut and Radio Amateur W8EDW. My last video I built a remote antenna switch. The reason for that, if you've watched any of my other videos, I run conduit from my basement shack out to my shed, which is where I have my remote antenna tuner, and now I have an antenna switch out there as well. So I can switch antennas from my 43-foot antenna to a 10-meter antenna. For some reason, my 43-foot antenna just didn't want to tune up on 10 meters, so that's what prompted me to build that switch. But anyway, a lot of guys were commenting, why did you run a 12-volt line through your conduit when you could have controlled your antenna switch with a bias T? Then that way you wouldn't have to have a separate line running through there, and which made sense. So I got to looking around at bias Ts and decided to build my own. And so that's what this video is about. We're going to start from scratch and build our own bias T. So stand by and I'll show you the pieces, parts that it's going to take to do this. Be right back. So before we get into the actual parts themselves, let's take a look at the schematic diagram. This design was by Phil Solis. His amateur calls AD5X, and that's the circuit we followed here. The reason for a bias T is that we want to be able to use the coaxial cable to carry 12 volts to a remote location. Maybe you've got a remote tuner or remote switch out by your antenna, and you don't want to have to run an extra 12-volt line. You want to be able to just use the coax to carry both. Well, in this case, let's go over here to the power supply first. The power supply sends 12 volts through this coil and then up and connects to the center conductor over here that's going to go out to our remote antenna or remote switch. But we don't want that 12 volts to go to the transceiver. We don't want 12 volts to be feeding into the output of the transceiver. So that's where the capacitors come in. There's a bank of 3 capacitors here. They're in parallel. In this case, they're 0.01 microfarad capacitors. So that DC that we're introducing into the line here can't go this direction. It gets blocked right here. And so it doesn't damage your equipment. The signal path for your transceivers through the capacitors, which they will pass RF, no problem. And it comes along here to the output. It's going to be going out to the remote switch or tuner. So that's simple enough. But let's look at the power supply section again. The reason we have this coil in here, and in this case, this resonates above 2 meters. So you don't want this coil to resonate at the frequencies you normally use. Like in this case, it might be anywhere from 160 meters up to 2 meters. But this coil, Phil did some research, and this coil actually resonates above 2 meters. So, when a coil resonates, it can pass radio frequency, and we don't want it to pass radio frequency. We want it to block everything on the radio frequency side because we don't want that feeding down into our power supply section. Also in this area, we have some safety devices. This is a varistor, just in case I'd get a DC spike somewhere. It actually will send it to ground. The capacitor right here is in there just in case some RF would get through this coil, and then it's immediately passed through the capacitor to ground. So those are just sort of a safety device. The resistor is in case something is open, you want a constant load on there. It just smooths out everything in the power supply section. Phil also did some experimentation and found out that by adding these capacitors here, shunt capacitors, 6.8 picofarad is the value on them. And so he's got one at each end. He's got one at the input and then also the output. And he found that by putting those in there, it actually smoothed out the SWR curve. So that's basically it. We have the DC coming in here, and then we have the RF coming in here from your transmitter. So kind of a cool idea, neat design, and I think once we get it all done, I think we're going to have a nice piece of equipment to add to the shack. So let's go on to the parts now. So of course the first thing we're going to need is a box. And some of the parts I got on Amazon, and some of them I got from a company called Mouser, and I'll show you the parts I got from whom. But anyway, the box that I got was a weatherproof box, and got this off of Amazon. But you can see it's just a standard electrical box with a lid. I had to order the lid separately. And here is, let's see if I can get this into focus for you. Here's, first of all, the lid. Oh wow, that's hard. Okay, now we got it. That's the lid. Now I got this off of Amazon. And then the box itself, I also got off of Amazon. And let me see if I can bring this in so it doesn't make it look so wacky. But it's a, like I said, standard electrical box with 3 holes in it. And those are the part numbers off of Amazon. So that's the box itself. And then the next thing is going to be some capacitors, and I'll show you those in just a second. The next component is a 0.01 microfarad capacitor, and these are a film capacitor, and they're rated for 1,000 volts. So that's the piece that you need next, and I was going to show you, if I can get it in focus here. This is from Mouser, and the cool thing about Mouser is you can order one part at a time from them. Unlike a lot of the other component companies, you have to order, 100 pieces in order to get it. So that's from Mouser. I ordered 8 of those, 4 for each box. The next component you'll need is SO239 antenna connectors, panel mount style, and I also got these from Mouser. They seem to be pretty good quality. They weren't real expensive, and what's cool is on their site you have options of different companies you can order from as well, but it all comes through them, so you can order, like I say, one part at a time. And there's the their item number and everything from Mouser. So let's see, we're going to keep going on the parts. Next component we're going to need is a 10K, and I got the 1/2 watt resistor, and I got those off of Amazon. The name of the company was eProjects, but here's the sticker on it. You get a bunch of them for pretty cheap. I think they were like $3 or $4 for all of them. So the next component will be these capacitors are 6.8 picofarad. They're a ceramic capacitor. I had to get these off Amazon. A lot of components are not that plentiful these days. You have to kind of hunt and peck around to find them. There's kind of a shortage. It is beginning to come back, but it is difficult to find some of these. So I found these on Amazon, 6.8 picofarad. And I was able to get these fairly quickly. Mauser was out of stock on them, and they said they weren't going to be back in stock until January, so I was like, well, got to find another place. And so let's see what's next. Next item is a 40 microhenry coil, and I got that from Mauser. And let me see if I can scoot this in here and get the numbers for you. But that's from Mauser. So, one more part we need. The last component I got is a varistor, and that's a protector. We're going to use that to protect in case the DC would get shorted or whatever. I got that from Mauser as well. And let's see if we can scoot this in here. So that's the Mauser part number and all that. So now we have to start putting this stuff together. So I'm going to mount my SO239s onto the lid of the box. So what I did was I put the box in the vise, and then I measured over how much clearance I got to make sure that the connector doesn't, overlap onto this. So I measured that, and then I measured the box cover distance, make sure I had clearance after I put the 239 on there. So I think we're ready to go. What I'm going to do is I'm going to actually drill both of these lids at the same time. I'm going to just overlap them like that, and then I'm going to put them on the box and then screw them down to the box, and then I'm going to drill both at the same time. That way they're lined up perfect, and it saves me a step. So I'm going to screw that down, and then we're going to drill the holes. So I've got the lids screwed together, and now got the one hole done. And all I've got to do is do this other one, and then we're going to go to a little bit larger bit. I think it's about a 1/2 inch bit is the size we need for the SO239s to fit in there. So I'll finish drilling those, and we'll see how it goes with the bigger bit. I've got the bigger holes drilled now. I used a 1/2 inch bit, and then had to ream it out a little bit farther, probably to about a 5/8 inch hole, and just to make sure these fit good in there, no problem there. And I could even mount them where this would come through from the inside of the box, because these holes are big enough now that the top part of the connector could come up through that hole. And so we'll kind of look at it and see which way looks the best. And I'll work on taking these lids off, and we'll try it. So I've got the connectors mounted in the holes. I don't have the nuts on them yet, but I used a square while I was drilling it to make sure that they're lined up and square to each other. And then I used an 1/8 inch drill bit for the mounting screws. So I've got all those in place, and now I'm going to take the lid off and actually mount these to the lid. I've got the SO239s mounted and tightened up all these nuts right here. I made the screws a little bit long so that way I can put a nut on there, and when I'm attaching lugs or whatever to this, that I'm going to be used for ground. But anyway, the first thing I'm going to do is put together the 3 capacitors that are in the middle of the diagram here. here's the last piece that I have to mount on the panel. And I found these in Amazon. It comes with the female panel mount and also a matching plug. And you get 5 of them for like, I think it was $10 for those pairs. And I'll give you the number that I used on Amazon. That's the number. So I'm going to get busy and drill that last hole and mount that on there, and then we'll start getting the soldering gun hot and start soldering everything together. One of the last items we have to install on the lid here is the DC socket. I think I'm going to put it in this area right in here. I think it'll fit in there fine. And so that'll be the last pretty much of anything that we have to drill into the lid. So I'll get working on that. I got the hole drilled for the DC connector, and now we just need to see if it is going to fit. I had to ream it out a little bit, I think, with the step bit, but yeah, it seemed to be just enough to do it. And so now got to just fasten it on there and do the other one. So the 3 capacitors are shown on the schematic diagram right here. These are the 3.01 capacitors. And then what I'm going to do is mount these between the 2 hot posts on the SO239. But you can see what I did here is I twisted the 3 legs together, and then I'm going to bridge the two SO239s. And I'll show you how I'm going to do that. So here's the 6.8 picofarad capacitor right here, and you can see it's going from this center to the capacitor, and then from there down to the ground. And then we also have one leg of this triple capacitor set up. It's wired into that same part of the coax. So that's the one end. So I've got this side done that had the triple capacitors and then the 6.8 picofarad. So that side's done. Those are the only 2 things we have to hook to this particular connector. So now we'll look at the other side. So I'm going to turn this around so that you can better see what's going on this side. And since the coil has to be tied to a number of things, like has to be tied to another capacitor, has to be tied to a resistor, has to be tied to a varistor. So what I did was I put a terminal strip here that I can tie those things to. So like the one end of all those components tie to the coil wire, and then the other end of all those components is going to tie to ground. So I'll start working on that, and we're almost there. So the coil tied to the SO239 center. The other end of the coil comes down to our terminal strip, and on the terminal strip you can see that there is a resistor. That's our 10K. There's a 0.01 capacitor, and then the blue component here is the varistor. All of those tie together to the terminal strip and also to the plus side of the DC socket. Then the other side of the components go to the ground side on the terminal strip, and then all their ground connections tie to this negative side of the DC socket. So that's basically it, and we are pretty much done with it. Now we have to do some testing and see if it works. The first test we're going to make is making sure that the DC voltage is going where we want it to go. So I've got the first box hooked up. The DC is going to this power supply right here. So let's switch on the power supply. And then our voltmeter. And then we're going to check the first connector. It should have about 13 or so volts coming out of there. Let's see what we got. Yeah, 13.67. So that one's good. Now the second connector, we shouldn't have any voltage at all. Those capacitors should be interrupting that. So we'll put it on there. Now it's basically 0. So that's good. That's the first box, and now we'll check the second one. Okay, we've got the second box hooked up, and the power supply is still on, so we're going to go with the first connector again. Into the hot center first, and this one should also have about 13. It does, about 13.6. So that's a good sign, and we'll go into the second connector. Shouldn't have anything, and it does not. So all that is a good sign that the boxes are probably wired up correctly, and the next phase is going to be, I'm going to actually bring a little test set up here on the bench. I'm going to take my little transceiver, hook it up to a piece of coax, run it through the first box, with another piece of coax to the second box, and then to a dummy load, and see what we get. So for this last test, I'm going from the power supply that's right next to the transceiver there, and then to the right, I'm coming out of the transceiver and going into that first bias T box with coax, and then from there, it's going over here to box number 2, and then from there we're going into a SWR and power meter, and then to our dummy load. It's on the very end there. So first thing we're going to do is make sure that the DC is correct, and it looks like it is. Have about 13.6 volts. And that's coming out of this box right here, which is going to be the one out in the shed. And then the DC in is coming in from the same power supply over there to this first DC connector. And then you got to remember that out in the remote position, it's going to be just the opposite. In other words, the DC is going into this box, and then when you get out there, you're going to come out of the same jack, and that's going to be an output, DC out, and that's going to be going to our equipment out there. So one thing I want to do is check for the signal, make sure that it goes through this system pretty well and doesn't interrupt anything, the fact that DC is going through it right now. So I'm going to key down on this transmitter. We're going through a dummy load, so it's really not going anywhere. Let's take a look at that meter over there. So the last part of the test, I wanted to make sure that the bias T's weren't creating some sort of a strange SWR or soaking up a lot of power. So I'm going to key this down, and we'll take a look at the power meter over here and then the SWR and see how it is doing. So I'm keying it down right now. And there I'm at full power, and the SWR is real good on it. So pleased with that. I think this project turned out really well. So now the only thing left to do is we have to label it up a little bit. I'm going to label where the DC in and DC out is going to be, and the RF in and RF out. And then we'll be pretty much done. I decided to put some labels on them. This is the one over here that I'm going to use in the shack. You'll see the RF in here and then RF out. And this is where we're going to plug the DC in. It's going to go over the coax. And then in the shed, you'll see the RF in here, RF out, and the DC out. What we're going to use for tuners or switches or whatever remotely. But anyway, I really appreciate you guys hanging in there watching this video. It's been a little while since I had one out. I'm going to try to put them out a little more consistently. But give me a thumbs up and please subscribe and give me a comment. Let me know if you like it or you don't like it. And we'll catch you on the next video. Thanks so much. Bye-bye.